John and I are so excited to be here with the other panelists, and also we have been amazed by their topics. We look forward to adding more provocative ideas to the dialogue regarding to design education. John, would you like to say something?
Yes. Hello, everyone. I hope you're all doing well. We're presenting from Cambridge, Massachusetts, and as Sheng-Hung said, and Verena, our presentation is on experimenting with design thinking and system engineering methodologies, which we hope will spark new ideas for this community. So Sheng-Hung and I are from the Integrated Design and Management program at MIT, which we refer to as IDM. And IDM is a graduate program that teaches human-centered design. The program brings together designers, engineers, and business people in the same room and teaches interdisciplinary skills needed to create products and businesses that have societal impact. And so as Verena mentioned, Sheng-Hung's background is in ID and EE. My background is in business, so I think it gives you a sense of how different perspectives can collide and hopefully mash into something really exciting. And we're excited to get going with our presentation.
So before we start, we'd love to acknowledge our mentors who have guided us along the way to written this paper. First and foremost is Professor Ed Crowley, who teaches system engineering in our Astro department at MIT, along with his colleague, Professor Olivia Dweck. We also received support from MIT H Lab, led by Dr. Joseph Coughlin and the research associate, John Rupnik. We have two John with us today. Lastly, Professor Jonathan Champion has been a guidance force in the development of our ideas around new methodology for the design communities.
So today we're going to share with you a brief history of design thinking and systems engineering before we introduce a couple of experimental techniques that we hope can help designers in their craft. I will take you through the key differences between design thinking and systems engineering, and Sheng-Hung will show how a designer can expand on his or her craft by drawing upon the techniques from both methodologies. And finally, we'd love to hear from the audience through Discord about where you might apply these ideas that we are presenting, and we'll leave some room for Q&A. So let's get started. So the word design thinking is one that almost everyone in this conference is familiar with, and it's widely accepted as an approach or route to human-centered innovation. But where did these ideas, the ideas that underpin this term, come from? Many educators attribute them to this man pictured here, John E. Arnold, a professor of mechanical engineering and business administration at Stanford University in the 1950s. John was also a professor at MIT, by the way, just want to point that out. And in 1959, he wrote an influential book called Creative Engineering, which detailed his ideas on how a designer can intentionally develop and invent novel solutions to problems. And this book presented his theories and methods for creative problem solving. And from those seeds, many design educators and practitioners came forth to experiment with the ideas and carried them into what is known as design thinking today. So there is no single definition of design thinking, but this one by Tim Brown of IDEO describes it quite well. Design thinking is a human-centered approach to innovation that draws from the designer's toolkit to integrate the needs of people, the possibilities of technology, and the requirements of business success. And we've seen many incredible, iconic products from the field of industrial design that have delighted users around the world through this method. And there are many variations of this diagram, but designers more or less come back to the same 5 steps of empathize, design, ideate, prototype, and test. And design thinking is now not only used by creative agencies, but also by organizations that have bought in, large and small. And some of these organizations have been design-led from the very beginning, and some have gone through several transformations to remain innovative and competitive, highlighting the importance of the ideas that have emerged out of the design community. So now let's switch gears. Where does systems engineering come from? Systems engineering emerged from the 1940s as an engineering discipline for inventors and researchers to grapple with complexity. The first uses of systems engineering began at Bell Labs, one of the greatest, if not greatest, research lab in American history. And pictured here is William Shockley, John Bardeen, and Walter Brattain, who invented the transistor at Bell Labs in 1947. And that completely transformed the world of electronics and personal computing. But there are traces of systems engineering in ancient times as well. You can see the output of this engineering discipline in the Great Wall of China, the Egyptian pyramids, the Roman aqueducts, and the Greek Parthenon. And all of these massive constructions require the same mindset needed to create modern day systems. So how do we define systems engineering? Like design thinking, there's no single definition, but we'd like to point to one given by the International Council on Systems Engineering, which states, systems engineering is a transdisciplinary and integrative approach to enable successful realization, use, and retirement of engineered systems using systematic principles and concepts and scientific, technological, and management methods. Now that's a mouthful, and we're gonna break that definition down. What is an engineered system? Well, one iconic example is the lunar rover developed by NASA in its Apollo lunar program. It was actually during this era, the 1950s and the 1960s, when systems engineering really took off, spearheaded by government and military-led R&D. And to give you an example that you can probably relate to better than a lunar rover, we have here a car with thousands of parts that interact with one another that have to be integrated into an engineered system to then deliver to the user an enjoyable driving experience. And so I want to emphasize here that systems engineering affects us in so many ways. We are all engaged with the output of this methodology, which has brought us revolutions in communication, transportation, space exploration, and more. And so I'd like to bring you to another definition to break this down further. What does the word system mean? Again, according to the International Council of Systems Engineering, a system is simply an arrangement of parts or elements that together exhibit behavior or meaning that the individual constituents do not. And the defining framework for developing such systems through systems engineering is called the V model. And the way you read this is down the left side to the bottom of the V and up the right. And without getting into too much detail, what you need to know is that the left side of this framework is about designing for many stakeholders, moving from concept development to requirements definition to systems architecture. And what we do is we break a system down into its parts. We call them subsystems. And at the bottom of the V, we engage in subsystem design and evaluate the trade-offs between the subsystems so that they can achieve a certain level of output for the whole system. And on the right side of this framework, it's about integrating these subsystems, testing them, and eventually deploying them. You could probably hear some similar themes, between design thinking and systems engineering at this point. But I want to highlight the differences. So the first point of difference is the entry point. Design thinking begins with understanding the user pain point first, but in systems engineering, we understand the functional requirements first. The system's output takes precedent over what the user experiences. The second point of difference is the thought process. In design thinking, we follow a diverge and converge thought process to explore ideas and then narrow those ideas down to a solution. And in systems engineering, we decompose a system into a subsystem, and then we integrate these parts back into a whole. And last is the outcome. In design thinking, the goal is to create human-centered products, services, or experiences. And in systems engineering, the goal is to achieve emergence, which is the idea that the functionality of the system is greater than the sum of the parts. And so these two methodologies definitely have their limitations. And so I want to point to Thomas Both, who is a director for a program at Stanford D School called Designing for Social Systems. And he wrote this beautiful piece called Human-Centered Systems-Minded Design. And in that article, he describes the limits of these two ways of thinking. So in the case of design thinking, the design solution may address the symptoms of a problem instead of the root cause. Design thinking may also address human needs that are not necessarily impactful, and it could also overlook downstream consequences of its creation on stakeholders or society as a whole. In the case of systems engineering, it's difficult to see the motivations and actions of players within a system, and especially when it comes to human behavior. You look at NASA, you look at the system. NASA doesn't go into this asking the astronaut what he wants to experience when he goes on the moon. NASA needs to ensure that the system works. And it is difficult in systems engineering to test your hunches and assumptions. And the types of solutions tend to require significant resources to test. So this article, we highly recommend you folks to read it. It's a beautiful piece. And so the question Sheng-Hung and I asked was, how can we equip human-centered designers with new techniques so they are empowered in tackling system design challenges? And I'll hand it over to Sheng-Hung next to share our experiments and ideas.
Thank you, John. So I'm going to share like experimental techniques that we're going to apply for our project. So if we revisit what John's mentioned about V model, so OPN, Conops, the two techniques, it kind of sit across like concept development and system architecture. So today I'm going to share like the modified OPN and Conops across different scale of project, from products, services, and experiences. First, let's talk about OPN, Object Process Methodology. So before I talk about OPN, I would love to share like one service project case study that I worked with MIT to solve like the design challenges. The design brief is how might we create an informative yet delightful MIT campus tour experiences for both students and visitors in the lens of service design. So we did like a very solid field research, brainstorming, prototyping, testing, refinement, and all the like design thinking process. Apply like both like 5-week experience design method and also OPN to kind of compare these two methodology. So let's move on to like, so this is like the next slide. So this is like the first like 5V experience like design models that we use, like, so 5 key kind of like a key touch point from entice, enter, engage, exit, and extend. So kind of like map out all the experiences for this project. And then we put in the context of campus tour experiences, we try to think how can we like map everything together, use like 5V experience models. Next slide. So from entice, how do we attract students, visitors, and also how do we like design the very immersive and great campus tour experiences. And then let's talk about OPN. So what is OPN? Object Process Methodology, OPM, is a modeling tool to represent a complex system in a graphical and textual way by showing the structural relationship between two fundamental elements, object and process. So one very simple example is like, you can see the Sharpies I have. Oh, it's hard to see. So pen or Sharpies is the object, and the process like writing, right? And when writing stuff consume the power, the ink from the pen, so that's like a link between the object and process. Let's move on, next slide. And then this is like very simplified graphical view to see OPN. So in here, you can see like one system, and within one system, there's a 2 subsystems. And then here we have like 3 processes and 3 elements. So in order to generate like element 2 from process 1 needs to consume element 1. So this kind of the very basic and simple way to understanding OPN. I'll use a real example to show. So here in the context of like campus tour experiences, you can see that the main function for campus tour is like establishing human-centered campus tour experiences. That's the main function or process. We want to generate or train more great, like talented campus tour guides. So in order to do that, we need to consume or require the resource from school, from students, from people, even from the environment or from the university. So that's kind of the way we use OPN in the context of campus tour project. If we zoom in, you can see like not just campus tour experiences. We also think about people might need to do sightseeing. They might need to hiring students, so different needs, different functions or process within the overall goal, like design better campus tour experiences. So if you look at like in the context of product design, we're going to design like a LED assembly light. That's the one project we want to test. So here we want to use like a module-based system engineering language to kind of design its framework, to kind of revisit design thinking process. If we go to the next slide, you can see we do follow the not traditional, typical design process from ideation, prototyping to testing. And then we use OPN to view the whole process as a system and what are the subsystem elements in the systems. So you can see in this project, you see, okay, lamp assembling is the kind of like a main process or functions, right? And then what are the element object within this? So lamp for sure, we definitely have designer who designed the lamp. Users, one of the component because they're going to use this lamp to do something. Require power, also require LED holder, the nano board, connector, and also some element materials. If we zoom in a little bit, you could see like for the lamp assembling, we also need to think about how do we print this stuff? How do we connect this element? and how do you make sure, add a light component, make sure it lights up. So these are like sub-process or subsystem within the main systems. So now let's move back to see, okay, the typical design thinking process, like 5E user journey as example. And also think about, I just mentioned OPN, the simplified diagram. It could be like, this could be one of the potential way to combine these two. So the ideas of this diagram is like, if you view like, how to say, outside in, like it's very comprehensive. You could still see like the journey from the very beginning, the key touch point, entice, enter, engage, exit, and extend. But if we zoom in, we could break down each touch point into like an object and process model. So like system engineering model. So we could have like very comprehensive, but also a very like sophisticated view to the system. Next slide. So in conclusion, the diagram illustrates how OPN and user journey can be combined to empower a system designer in balancing the user journey against the system architecture and vice versa. So for the future study, the benefit of merging the two methodology for the project team in capturing the user journey comprehensively from emotional aspect, like scenario, moment, user behavior, and from the functional aspect, like object, system, subsystem, to build a well-rounded capacity to solve the systematic service design challenge in the area of change. So that's one of the key takeaways for these two methodology techniques. And then let's talk about like the concept of operation, we call Conops. So we did a lot of research. So the Conops is basically like a verbal statement or graphical to describe a complex system. So the Conops includes a sequence of phases, estimated timeline for deployment, and overview of important system characteristics shown in a qualitative and quantitative way. So these are the same like different definition for Conops. So one of like very iconic like diagram to show Conops is this. It's a Conops of Max Launch Abort System from NASA. So if you see the diagram like more in the holistic way, like Conops could encapsulate the project mission in a diagram with the estimated time and approximated location of the deployment, the sequence of each phases, and highlight the features of the system to reveal the scope of the mission in a quantitative and qualitative way. So this is kind of the basic ideas of Conops. And then we use our class project example. So mainly we designed a proposal for like a NASA competition called RASCO. The idea is that I want to build the grid solar system on the moon, and then use that as a topic to apply the system engineering methodology like Conops and OPN to learn and know how we merge together. So the team talked about the key phases, mission, milestone of the space project. And this is our like a very first draft of Conops on the whiteboard. It's super raw, super like sketchy, but we try to understand how can we encapsulate the whole journey of the mission. So this is our final Conops. You can see from phase 1 to phase 8, how can we launch the spacecraft, the material to the moon, and then establish the solar grid system on the moon. And then we talk about design scenario. I think this is pretty common for designer because we use it all the time. Basically, these are different definitions of design scenario. If we go to the next slide, and then also next slide, the quickest way to say design scenario is like, it could be represented as image or as a graphic. You kind of tell like who, when, where, what, and how. So kind of encapsulate in one image. And this is our like the very first sketch of our space project. We tried to like break down like 4 key moments to illustrate the scenario. And then this is the second round of the sketches of the selected scenarios. And we have like 8 sketches like this for the final selected scenario for the space project. And we only select 4 to share with you guys. And then what if we combine like a Conops and design scenario to put in the one diagram, and this is how it looks like. So we have 4 like one Conops, but like 4 different scenarios to show. So I think the idea you can see like let's move to the last slide of this. Yeah. So typically a Conop is a single diagram that communicates an abstract view of a system, but does not immerse stakeholders in the detailed design. It's too abstract or too like high level. So in our study, the experimental Conops that was developed to consist of like valuable information. So you could see like scenario 1, 2, 3, they have who, where, how, what, to convey a more nuanced pictures of how a system functions for its stakeholders.
So unless you work for NASA, you're probably not designing lunar energy grids. So why do these concepts and ideas matter? Because when you look around today, our world is suffering from so many system-based problems. One doesn't need to look very far to see problems in transportation, in education, energy, health, the environment, and many, many more domains. And so designers have always been creators of new solutions to problems, and the design craft continues to evolve to meet challenges of our time. And so through our presentation, we have observed this tension between design thinking and systems engineering. And so what we want to emphasize, the three main takeaways. As projects grow in complexity, designers will need tools and techniques to diagnose problems from a systems perspective and to design for systems that positively influence human behavior. And so the two ideas that Sheng-Hung presented are modifications of techniques from this field of systems engineering. OPM as a model-based system language can allow a designer to make trade-offs between the user journey and a system structure and its functionality. And the experimental Conops can help designers illustrate that abstract and deconstructed view of a system at the same time.
So now you've seen like a system engineering and design thinking, and how does this two methodology or techniques or framework merge? So I think in our stage, we're not really merging or combining or even like integrating. We're more like curating the two techniques or methodology. And here's some opportunities for us, we think we're willing to share with you guys. So also for us, like it's a question, like, so the first one, what should be the criteria for determining whether a project or opportunity space is suitable for application of these two methodology? And second one, what are the conditions necessary for a new methodology to emerge? The last one, how can you apply the modified Conops and OPM techniques into your craft? So we don't, this is just the beginning of the question for us. We don't have answer, and we'd love to have your thoughts, ideas on the discourse. Let us know, we'd love to chat. We want to learn more as you guys, because this is pretty new for us. And then we'll also post some like references, like the paper or books that we surely totally recommend to you guys as a reference to check. And that's it for us. Any questions, thoughts?
Well, thank you both. What happened to the other John? I thought you guys were, there were three. Not coming? Anyway, I think we have really only time for just one question. So for the audience, please put in the chat what thoughts this talk sparked in your mind. I'm sure it's going to be, those guys will answer those a little bit later. And just one question I think we have. So what's next? What's next on the agenda? Like how can we apply it? Like how can we like take it in the classroom or in our practice? Yeah.
Yeah, I think definitely there's a huge opportunity for combining and merging these two techniques or methodology. I think the next one is like, now we're kind of facing a lot of like systematic challenges, and how can we apply like human-centered way to kind of tackle this systematic challenges with design, with like system engineering method or like thinking, because like I think scaling impact is quite important. I mean, for me, I don't know what's John's thought on this.
I think in terms of what's next, you know, methodologies require a lot of experiments to prove that they are truly a methodology of use. And so those final three questions we left with the audience are really questions we're asking ourselves all the time as we tested this out. We're trying to figure out what type of project should this method be used, and how can you test it out multiple times, whether it's in the classroom or in the field, to see if it's actually useful. And hopefully through the contributions of the entire design community, maybe we can spearhead some new ideas that can result in our society addressing our system-related problems.
What might be interesting if you guys could drop your questions in the chat and then have people respond to that. as like a segue into the next phase. So thank you again for an awesome talk, very inspiring. Time is flying, I have to say. So we're gonna have to move forward, as much as I would love to continue talking to you. So, but maybe on Discord or maybe in the chat later. All right, thank you so much.
Thank you.